In this video, we are going to continue looking at the section 11.5 example problems. We are starting with this one. A wholesaler is considering the purchase of a load of lumber. He calculates that the probabilities of reselling the lumber for $10,000, $9,000, and $8,000 respectively are 0.27, 0.33, and 0.45. To ensure an expected profit of at least $3,000, how much should he pay for the load? So, the main thing that we want to consider here is we know what the expected profit we want is. So now we need to figure out what the expected value for these particular pieces of information are. So we've got 10,000 times 0.22 plus 9,000 times 0.33 plus 8,000 times 0.45. Okay, well, that gives us for the 10,000, that's 2,200 plus 9,000 times 0.33. Bring out the calculator. $2,970 plus 8,000 times 0.45 is 3,600. We add those up. To get $8,770 in expected value for the sale of the lumber. If he wants an expected profit of at least $3,000, we subtract $3,000 from this and get $5,770. He should not pay more than $5,770 for the lumber. A farmer will realize a profit of $150,000 sorry, something was in my way, on his wheat crop unless there is rain before the harvest is in which case he will realize only $40,000. The long-term weather forecast assigns rain a probability of 0.16. An insurance company offers crop insurance of $150,000 against rain. For a premium of $20,000, should he buy the insurance? To figure this out, we are going to figure out what the expected value is with and without the insurance. So if he buys the insurance and it rains, he gets $150,000 for the insurance plus $40,000 for the profit from the crops and minus $20,000 for the insurance premium. That leaves a total of $170,000 if it rains and he gets the insurance and he buys the insurance. Now, if he, so let's do it this way. If he buys if he does not buy the insurance, if he does buy the insurance, we'll do it this way, sorry. We have these possibilities, rain and no rain. Net profit is $170, $170,000. Without the insurance, if it doesn't rain, the net profit is $130,000. Since then, he'd be getting $150,000 for his profits and losing $20,000 for the premium. The probability is 0.16 for rain and 0.84 for no rain. So that gives us a product here of 27,200 for the rain and a product of 109,200 for no rain. Add those up, and we have an expected profit of $136,400. However, if he doesn't buy the insurance, we do the same calculations. For rain, he's only getting $40,000. Still a probability of 0.16, and the product there is going to be 6,400. For no rain, he's getting $150,000. Probability 0.84, and a profit of 126,000. A product of 126,000. So here the expected profit adds up to $132,400. Since the expected profit is higher if we buy the insurance, we should buy the insurance. Next. We are told to toss 2 coins 50 times and use the results to approximate the probability that the crossing of RRP plants, pea plants with one dominant red and one recessive white gene will produce 3 successive red-flowered offspring. Now, the book gives us a list of heads and tails. So we've got tails, heads, 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 tails, heads. Okay. Now this is tails, heads, heads, head, tail, tail, head, tail, tail. I don't want to go through this piece by piece, but the basic idea is that when we flip 2 coins, this approximates the same, approximates the way that the possible results from the crossbreeding of the two pea plants. Notice that right here, that equates to a large red, 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 white. If you go to page 651 in the textbook, you can do that online, you'll see a list of these, and Well, the probability of we find that there are 20 out of 48 20 out of 48 of these 20 out of 48. There are 20 places where 3 red plants appear in a row out of 48 possible places where 3 red plants could appear in a row. And that comes out to 5/12, which is approximately 0.417. If we check the theoretical probability of this, we know that there's a 3/4 probability of getting a red pea plant in any given interbreeding. And we cube that to see the probability of getting 3 in a row. Well, that's 27 over 64, which is approximately 0.422. So we can see that the experiment that they did in the textbook comes out very close to the actual value. A couple plans to have 5 children. Use random numbers to estimate the probability that they will have more than 3 boys. And here, the okay, so we have a random number generator in table 17, which is on page 652 in the textbook. And if we look at that, all we have to do is we let each sequence of 5 digits represent a family with 5 children, and arbitrarily associate odd digits with boys and even digits with girls. So if we go down this list, we can see how many times more than 3 boys appear. And I'll just do a few of these because, again, I don't want to copy down everything from this list. We've got 51592. That would be 4 boys, 1 girl. 77876 gives us 3 boys, 2 girls. 36500, that's 2 boys, 3 girls. 40571 gives 3 boys, 2 girls. And we're asking the probability that they will have more than 3 boys should be pretty low. Ultimately, in 10 of the 50 situations, or approximately 0.20, actually that's exactly 0.20, 1/5 of the situations, we find that the couple has 4 or 5 boys. So this is the probability of more than 3 boys. And that actually seems a little high to me, but I could be wrong about that. Toss 2 coins 50 times and use the results to approximately, that's the wrong page. I'm sorry. I just took the same page that we already went over. We're on this one. Use random numbers to estimate the probability that 2 cards drawn from a standard deck with that if 2 cards are drawn from a standard deck with replacement, both will be of the same suit. Okay, so 0 and 1 mean clubs, 2 and 3 mean diamonds, 4 and 5 mean hearts, 6 and 7 mean spades, 8 and 9 are disregarded. So here are the values that were collected. 5, 7, 3, 4, 0, 5, 0, 3, 6, 1. 2, 7, 7, 4, 4. 0, 5, 4, 2, 2. 7, 5, 4, 6, 0. 1, 3, 1, 6, 7. 1, 5, 0, 0, 6. And 7, 1, 5, 1, 6. Okay, so using our correspondence that we set up, 0 and 1 are clubs, 2 and 3 are diamonds, 4 and 5 are hearts, 6 and 7 are spades. So heart, spade, diamond, heart, club, heart, club, diamond, spade, club, diamond. 7 was spade, spade. 4s are hearts. Club, heart, heart. Diamond, diamond. Spade, heart, heart. Spade, club, club. Diamond, club, spade, spade. Club, heart, club, club. Spade, spade. Club, heart, club, spade. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 out of a total of 39 pairs of digits, which is approximately 0.23. The theoretical probability for drawing two of the same suit is 0.25. So this is a pretty good estimate. That is it for this video and this section. If you have any questions, please get in touch.